Okay, we're going to be dealing with mean, median, and mode. These are all our measures of central tendency. Measures of central tendency basically means that you're looking at the gist, or how do we summarize the group with one score. And you might ask yourself, well, why do we need to summarize a group with one score? And the answer is really because you can't keep of all that data in your mind at once. If I said to you, I have 3 boys. They're 12, 9, and 7 years old. That's easy enough for your brain to keep in your mind. But if I said to you, my nieces and nephews are 18, 15, 13, 11, 9, 7, and 5, and 3, and not 1 yet. You probably can't keep all that information. There's 10 of them. I have 10 of them. I also have 2 nieces on the other side. And if I keep adding numbers to that, the ages of my nephews and nieces, you'd get confused by. And you wouldn't be able to hold it all in your mind. So if I use a measure of central tendency, you're able to think about that entire group of people, that sample of people, understand what's the gist or the summary or the middle point or the most frequent. Those are our measures of central tendencies: the average, the middle point, and the most frequent. And that's where we get mean, median, and mode. We're going to start off with the mode. Not a la mode, although I'd love some ice cream right now. Mode is the most frequent number in a data set. This can be used for categorical data too, because you can count up frequencies of, say, if I said, how many of you are wearing sandals, Havaianas or Flohos, or what are those? I got some over there. Oh, Quicksilver. I got Quicksilver sandals. We said, what type of sandal do you have? Mine are flip-flops. Some of you have the strappy kind. We all have sandals, not all of us, but most of us, and so there are different types of that. And if we did a modal search for that, we would find that there'd be like 10 people who had the Old Navy kind. I have some of those too. $2 at Old Navy. They were great. They lasted several years. But that would be the most frequent one, right? If there was 10 of those and everybody else had like, one of this kind or one of that kind, the one that's the most frequent, even if it's a categorical one, that's called the modal. If we have, say, a distribution of scores, and the book uses the distribution of scores, and it says, here's this data set. It says, how many dreams do students have in a week? And so it measured these 10 people, and it said that they had I hate it when these things don't work. Seven, 8, 8, 7, 3, 1, 6, 9, 3, and 8. So, as you can see, there's variability here. That means that they're not all the same score. But also, if we wanted to find out, okay, if there's a college student out there, we want to use this data to describe to them what's the most frequent number of dreams a student has in a week, then we would find that 8 is represented thrice. So the 3 times that we have 8 represented, that is more frequent than any other score that we see. Although 9's represented once, 1's represented once, 6 is represented once, 3 happens twice, and 7 happens twice. So now we have multiple iterations of numbers, 7 and 7, 3 and 3, but we have 3 of 8s. So 8 becomes the mode. So the most frequent score in our data set here is 8. Now, these are very active dreaming people. I don't think people dream that much, but whatever, this is made up data. As much of the data that we'll explore in this class is all made up. The issue with making up the data is, rather than use real data, which would give you insight into real people, there's some issues of ethics or confidentiality with regard to using real data about people. So the book makes up data, and I'll make up data, and you'll make up data. Because what you're actually learning is the process by which we determine this particular mode. You're not learning about student dreams, but you can imagine if there was really a study, if somebody really was spending all their hard research time on finding out about how many dreams college students have, this might be something that they would do, and they might represent and tell people, hey, the modal dreams for students was 8. That is the most frequent thing that we saw in our data set. So that's a mode. Super easy. Remember, I told you already, this class starts out incredibly easy, and it develops from there to get more and more complex. Understandable, but it's going to take more cognitive effort for you to understand. This is very easy. My 7-year-old, he's upstairs right now. I could bring him down here and say, which one's the mode? The mode's the one that you see the most frequently. And he'd be like, well, there's 3 8s, so I think it's 8. That's not the issue here. The issue is that why would we do that? Is we would use categorical, or when we're using categorical variables, remember those are the ones that differ only in name, they're nominal, then we would use this. I'm using an example of the numeric version here just to demonstrate that it could also be shown in a numeric variable. I hope that's enough mode for you. I think I'll ask you one question about the mode on one exam and we'll be done with it. Why? Because it's easy to understand, and so I think you got it. And secondly, because we don't use it often. It's not something that you're going to see a lot of modal presentations. There is something else about the mode that you should know. Oftentimes people will talk about a bimodal distribution. Okay? What's a bimodal distribution? Imagine that we didn't have 10 in our set, we had 11. And now I have 3. So now there's not 1 3, not 2 3s, but there are 3 3s, as well as 3 8s. That would be called a bimodal distribution, and we would say 3 and 8 are the mode. 3 and 8 are the mode. It is a bi meaning 2, modal distribution. Unimodal distributions mean there's only 1, and that's what we'll see when we go to the normal curve. Bimodal distribution, I'll give you an example of that. So oftentimes, we looked at the scores on histograms, like what normal scores would be like on my exams for the demonstration of a histogram. Often what actually happens on my exams is that I get a bimodal distribution. I'm back. Bimodal distributions is often what I see. So again, this would be the percentage of people who get a certain score, and then this would be their score, 0 to 100% on an exam. Usually what you'll see is that if I plot it out, it looks kind of like this. So that what ends up happening is, there are 2 modes. It doesn't have to be exactly the same number of people that get them, but what we see is that there's 2 sections. This is a group of people that clearly didn't understand what we were talking about this portion of the class and didn't do the work, or a combination thereof, or maybe I screwed up presenting it. This is the group of people that did the work and understood it and got the right information. But you see, it's basically a bimodal distribution, so that there's very few people on the center who got kind of the average amount. Most people got all of it or very little of it. And that's called bimodal distribution. So that is the mode. All right, the next one on our docket is median. I'm going to write it right here in the middle. I'm going to write the median right in the middle because that's what it is. The median is the middle score. In fact, you've heard of median before. This is driving down the freeway and somebody says, watch out, there's an accident, they've pulled over to the median. If you're driving down the freeway, you know that the median is going to be in the center. It's the middle. It's not on off the edge on the side. It's the middle. So the median is the middle. And in numeric data, that's exactly what we have. So let's use that same data set that we had before. The 7, 8, 8, 7, 3, 1, 6, 9, 3, 8. But I'm just going to do something to that data. To find the median, you have to start with either the biggest or the lowest number, and you have to go through that numerically. So we're going to use the numerical sort of numbering, right? Lowest to highest. That's as simple as I put it. Oftentimes when students screw up a median on a test, they take the data as was presented, right? So I just presented that data, 7887319 or 7316938. I'm going to take that data now and I'm going to start with the lowest number, which was 1. So here's 1. And then we had 2 3s, if you remember that. And then we had 1 6. We had 2 7s. We had 3 8s. And we had 1 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good, I've gotten it correct. I did a little check there to make sure that I hadn't forgotten any of the numbers because, well, it's easy to forget numbers, and if you do simple checks like that, like count to say, did I get all those numbers? Because I know there are 10 numbers. We tested 10 students, we asked 10 students how many dreams they had in a week. Then I'm pretty sure I've made a good check that I've gotten all of them in here. All right, I'm gonna bring you guys in a little bit closer. All right, there we go. So these numbers, we have 1, 3, 3, 6, 7, 7, 8, 8, 8, 9. And we have to determine, well, what's the middle number? And we've put them in ascending order from the least to the greatest. So there are 10 numbers here. Do you remember I also altered that number last time to see what would happen if it was bimodal? We'll do that here in a second. But for this one with 10 numbers, we're just going to count to the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So right here in between these two is the median, or 7. If you have an odd number, right? If you have an odd number, then you take the 2 middle scores, 7 plus 7, 14, and you divide that by 2. 7. Pretty simple stuff, right? Again, it's not going to be the same way all the time. You might have a different distribution that has a different look to it. So I'll give you a different distribution where it's an even number of scores, and then you have to add the 2 numbers up and figure out Here's a new example. This one looks like the old one, but it's different. Now what do? We're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These two are our middle numbers. So now we're going to take 6 plus 7. 6 plus 7 is 13. And we're going to divide that by 2. Does anybody know what that is? 6.5. So now 6.5 will be our median. So now you know how to calculate a median. What is a median? It's the middle score. What does that mean? It means that half of the scores in a distribution, this distribution is just our data sample or whatever you want to call it. It's just a group of numbers together. Half of the scores in this distribution are less than that number, and half of this distribution are scores that are more than that number. That's what the median is. What do you do if you have an odd number of scores? 1, 3, 5, 7, 9, that's your distribution. Well, you just count to the middle one. That is your median. 1, 3, 5, 7, 9. 5 is a score that half the numbers are below and half the numbers are above. Not really, because you see there's an odd number here. So 5, conceptually you would split it into 2, an upper and a lower limit of it. And then the lower limit would go on this side and the upper limit would go on that side, and the same amount of scores are on that side as on that side. Remember, the same amount is important for median. So there's the same number of scores. Here we go. So 1, half of 1, 2, 3, half of 1, 2, 3. So the middle score, 5, means it's the median. If there's an odd number of scores, the median is the middle score. If there's an even number of scores, like we did in the 2 examples before, you take the 2 middle numbers, average them, add them up and divide by 2. That gives you the median for that distribution. So median. Where do you guys hear of median? When is median used? Well, median's used when a mean is a poor choice for describing data. That often happens when there are outliers in the data. We'll cover that later once we cover what a mean is and what it does, because the median is often used if there are extreme outliers. So if there's one or two scores that are vastly different from all the other scores in the distribution, then using a mean is going to really skew the average, and it won't describe to you what the central tendency of that sample is. A median would be a far better one because it's not susceptible to outliers. Where do you hear about median being used? Often you'll hear about it as median salary or median household price, right? So there are these things like, let's say you're out home shopping today and you wanted to know, well, what's the average home price? A smart realtor will tell you, well, we don't like to calculate average house price because that includes every single house that's sold, and there was a $13 million mansion that just sold. So if we said average house price right now, that 13 million is going to get included into the average, and then it's going to skew that data up. Or you might say that there was a really, really cheap house sold and it's a barely livable structure. It's a shack on a postage stamp of, rural county, but it counts as an actual house that was sold for $20,000. That's going to reduce the price dramatically when we include that sale into the average home price. So instead of doing those, the 13 million or the 20,000, what we're going to do is we're going to say, well, what's the house price that half the people paid less for their house than that and half the people paid more for their house than that? That's better information for somebody when you have skewed data to sort of say, what can I expect? If you know that the distribution of things like, say, home prices or salaries is skewed, then you'd want to use a median. For example, you can go on not covered California, that's the insurance one. Transparent California, the SACB does salaries, right? You can look up my salary, you can look up everybody who works for the state's salary. And if you look up who earns the most, there are several people that are earning millions of dollars a year. I remember it was the head basketball coach for UCLA the last time I looked. He was earning something like $5-6 million a year. Now, obviously, head basketball coaches at storied programs like that command a high salary. Most state workers don't command that high of a salary. So if you're like, well, what's the average state worker make? Knowing what the average state worker makes isn't going to make good sense for if you're going to go work for the state. You live somewhere near Sacramento, you might work for the state. It's a good job, good pension, stable job, good work environment. You're doing something good for the greatest state in the nation. But you shouldn't calculate in the highest paid person's salary into what you expect, because that's going to skew the data. And you shouldn't calculate what the lowest paid person for the state is, because you don't know, or is that an equivalent full-time worker? So what we should do is say, well, what's the average? And then we'll compare that to what's the median. And we'll see what the average is in a second when we do the mean. But the median is for those distributions that have big skews or big outliers in them, to give us a sense of what we would expect. What would the average person expect? The median doesn't take into account this giant outlier in the data, just like the mean will. And the mean will be skewed and won't be a good measure of central tendency to use if we know that there are outliers in the data. Oftentimes people do use the mean when there are outliers in the data, and that can be a misuse of it, right? If you're trying to make a sense of it, right? There's the classic quote that I like to use, it's on our syllabi: torture numbers and they'll tell you anything you want. You can torture numbers to say, well, look at this average. If you knew that the data was skewed and the mean was skewed in a direction to make the point you wanted to make, you could include the mean and everybody would be like, oh, it's the mean of that distribution. But it's more complex than that. You have to be careful about which measure of central tendency to use, because you want to describe the gist of the data with these numbers, but you also don't want to describe data that people can't rely upon to make their decisions. So that's the mode and the median.